Let's take a look at one very important limit that later on will be used to calculate the derivatives of all exponential functions. And the limit is of this ratio e to the k x minus 1 divided by x as x goes to 0, where this number k that appears in this formula, in the context of exponential functions, it was called a continuous growth rate. Now, if you take x equal to 0 and just plug into this ratio, well, you just get 0 divided by 0, so it's undefined. And instead, we will use this formula here that we actually have already seen before. If you recall, this is exactly the formula that we discussed that explained why k is called a continuous growth rate and also where this Euler number e is coming from. So first thing we are going to do is take this formula and take the nth root of both sides. So on the left-hand side, we'll get e to the k 1 over n. And on the right-hand side, the nth root will cancel the nth power, and we'll just get 1 plus k over n. Next, let's move this 1 to the left-hand side. So e to the power k 1 over n minus 1 is approximately k over n for large n. And then let's divide both sides by 1 over n. And you see on the right-hand side, 1 over n cancels, and we get exactly k. So finally, to get this formula, just think of 1 over n as x. So as n goes to infinity, 1 over n goes to 0, and we get that this expression here, e to the kx minus 1 divided by x, is getting closer and closer to this continuous growth rate k as x goes to 0.